What's up? What's up? What's up? It's your boy, the network. Hashtag lab every day. Y'all know what it is. Today's topic is subsection 3.1b, ARP, which is a subsection of 3.1, identify, configure, and verify IPv4 addressing and subnetting. This is a subsection in the exam CCNP route exam code 300-101 version 2.0. Let's look at the exam blueprint and see where we came from and where we are headed. All right, this is the exam blueprint. We got exam code 300-101. Again, I'm gonna say it again. Make sure y'all signed up for the correct exam, correct version. We just wrapped up the address types: unicast, broadcast, multicast, and VLSM. Today we are doing ARP section 3.1b. And after that, we're going to do DHCP, relay, and server. For now, we're doing ARP. So, ARP, simply put, is an acronym that stands for Address Resolution Protocol. Basically, you know the IP address of a specific device, and you are trying to obtain its MAC address. You know what a MAC address is, right? It's a layer 2 address. So before we get deeper into that, let's define the two different types of addressing, right? You got layer 2 addresses and layer 3 addresses. Layer 2 is a MAC address. If you look here in the green, a MAC address is a hexadecimal address that's burned into every NIC card of every networking device, and it's unique. You will never find two MAC addresses that are the same in this world unless you somehow spoofing it. There's two ways you can write the MAC address. You can write basically the two numbers, the colon, two numbers and the colon, all the way. It's 48 bits, or you can separate it into 3 sections by 4, as you see the second line. And the layer 3 address, that's what we've been studying this whole time. A regular IP address, for example, here in the red, 192.168.1.1. So IP addressing occurs at layer 2, data link layer, and layer 3 of the OSI model. Y'all remember the OSI model. I'm not going to show y'all that right now. If you want to learn that, I'll create a separate whole video. Actually, in the future, I'm going to do CCNA videos. But for now, I'm going to assume y'all know what the OSI model is. In order for devices to be able to communicate with each other when they are not part of the same network, the 48-bit MAC address must be mapped to an IP address. So basically, you creating a database and mapping the layer 2 address to a layer 3 address. 9 times out of 10, you know the IP address, you don't know the MAC address. That's what ARP helps with. Let's go to the official definition. ARP, again, is the Address Resolution Protocol. It's defined by RFC, I believe it's 823. I'll put a link in the description below. But it's a feature that performs a required function in IP routing. You would think, when we talking about ARP, this is a switching concept. You talk about layer 2, but no, it's required in IP routing because we need to know the MAC address of our router if we need to route. So that's why this is a subject in IP route and not necessarily in the switch exam. ARP finds the hardware address, also known as a MAC address, of a host from its known IP address. ARP maintains a cache, which we're going to go over, a cache table in which MAC addresses are mapped to an IP address. If you look here at the bottom, we got Fred and Barney from the Flintstones. I don't know why they picked that. I need the IP address. I need the address of 10.1.1.2. So Fred knows that IP address, right? So like if you looking for, let's say you was trying to get to a website, you know that's where DNS comes in. You know the google.com, right? But your computer's going to look for 8.8.8. He knows that IP address because that's what you typed in. And then he's going to send a broadcast, which is the ARP reply, and then all the computers heard it. You most likely not going to be in the local area network of Google. So your router is going to respond, which would be Barney in this case. Yeah, he looks like a computer, but it might be a router. And he's going to say, I heard that broadcast. That message is for me. Here is my MAC address. Barney might be your default gateway. So he's going to give you his MAC address, and you're going to remember, okay, now if I need to get to Google, I'm going to send messages to that MAC address, which is my gateway. and from there he's gonna look for Google, and from there we'll discuss that in later topics on how to get there. But that's how you're getting out of your network. So this is the ARP header. See, I almost said IP header. There's so many headers that are tacked on. This is tacked on to your Ethernet frame. This is the IP, the ARP. See, I said it again. This is the ARP header. So right here, you have several fields. When you're sending an ARP reply, which is the broadcast essentially, this is what you are sending. And let's go ahead and break down these fields here. I'll show y'all an example of that. And yes, packet tracer again, because I love the animation, and I can show y'all this header and how it works. Okay, so the ARP header is normally 32 bytes. Let's start off with that. As you can see, it's 0 here, 31. It's actually 32 bytes for this entire ARP header, right? We got the hardware type, protocol type. Protocol type is basically the type of protocol. It specifies how long the layer 3 addresses are in a message. Normally it's 4. You also got the hardware address length. Normally that's 6. Protocol address length. Normally that's, I believe it's 4. This is the op code, which is also known as the operation code. You can have either, it's going to be a value between 1 through 9 here. If it's a number 1, that's an ARP request. You're going to see when you open up the ARP header, if there's a 1 there, you know that that's a request. So he's actually essentially broadcasting, looking for a MAC address. If it's a 2 there, that's a reply. So you got it back and you got the reply. Now you know the MAC address of whoever replied to this ARP request essentially. And then you have the source hardware address, which is going to be your MAC address, the source protocol address, which is going to be your IP address. This is the destination hardware address. Obviously, you're going to be thinking to yourself, well, what's going to be there if I don't know the MAC address? That's the hardware address. Hardware address is also known as the MAC address, which is also known as the BIA, or burned in address. It's burned into the MAC into the NIC card. That's going to be a 0 because you don't know it if it's a reply, if it's a request. So you're not going to have anything here. And then you got the destination protocol address, which 9 times out of 10 you gonna know. So like if you send in a request, if you know the IP address of your default gateway, which was given to you through DHCP, that's where it's gonna go. And then when you get the reply, then once you know the MAC address, it's gonna be put into the destination hardware address field. Let's go ahead and pull up packet tracer, and I'll give you an example of that real quick. So we got the 10 network on this side. We got the 172.16 network on this side, right? I'm going to have him 10.10.10.2 ping one of these guys over here, right? And then we're going to investigate the ARP header. So he's going to ping one of these 172 guys, right? Let's have him ping 31.4. That's my favorite number. So we got, notice how we got 2 requests. We got our ICMP request, which is the ping request. And we also have an ARP request. Why? Because I cleared the, he doesn't know the MAC address of his default gateway. So he got to send an ARP request. Fast forward, that's being sent first, the ARP request. Let's go ahead and open him up and investigate. Inbound PDU. Notice this is our ARP header that's attached to our frame. See how it's the same guy? See, this is our ARP header, hardware type, protocol. We got the address length, the op code, etc. Let's go ahead and look at it. We got the hardware type is 1, protocol type 0, hardware length, like I said, is 6. That's 4. The op code is 1. Y'all remember what that was? It's a request. So it's a request. That's why it's a 1 there. Source MAC, that's my MAC address. This is my IP address, 10.10.10.2, right? The target MAC, I don't know it. So it's blank right now. And then the target IP is 10.10.10.1. Who is that? Let's see. Let's look at my PC. That's my default gateway. That makes sense? All right, moving right along. Ain't gonna get too deep into that. Once he knows it, the destination hardware address is gonna be right in this field right here. So when I first looked at the bullet point on the exam blueprint, I thought, oh, ARP, this should be easy. This should be like a 5-minute video. Nah, man, ARP gets deeper in the CCNP exam. You just know the basics of ARP with CCNA. At the CCNP level, we got all these ARP types. Now, I kind of knew about the reverse ARP and, standard ARP and inverse ARP with frame relay, which I didn't really discuss in the frame relay in the last video, which was frame relay in the last couple of videos. There are so many ARP types, right? We're going to go ahead and discuss some of these. We're going to play with a little bit of it in GNS 3. So first we gonna cover ARP, which is basically the vanilla flavor of ARP. This is your standard ARP, as defined in RFC 826. That was the number I was looking for. I'm gonna leave a link in the description below. Layer 3 devices need ARP to map MAC network addresses to MAC hardware addresses so that IP packets can be sent across networks. Basically what we discussed so far. Before a device sends a datagram to another device, it looks in its ARP cache, remember that basically the database inside the router, to see if there's a MAC address or switch. MAC address and corresponding IP address for the destination device. If there's no entry, the source device sends a broadcast message, which in this case is the ARP request, to every device on the network. Each device compares the IP address to its own. So in this case, Fred sends the ARP request. He says, who's got this IP address? Barney says, that's me. And he sends him back the MAC address. That's basically standard ARP, what we just discussed so far. I wanted to discuss static versus dynamic ARP entries. The static entry is basically an entry that you put into the router itself. You could just say, the MAC address and the IP address. You don't want it to learn it automatically. You just kind of put those entries in there. So you put IP address XXXX goes to MAC address AAA BBBB. And you just put it in there. I'll show y'all how to do that statically on a router in a little bit. There's also reverse ARP as defined by RFC 903. I'll leave a link in the description below. So reverse ARP is, as you guessed it, the opposite of regular ARP. You know the MAC address, but you don't know the IP address of your device. Now, you would think, where would this even come in? You might have like a diskless device that don't have any way to get DHCP, or it could be like you have a device that you need to get to. It comes in handy for like TFTP servers, and you have no kind of configuration on, say, a switch. If you have reverse ARP on a ARP or called RARP server, you could use that to kind of give. It's kind of like DHCP. Give your device an IP address. So reverse ARP is defined by RFC 903, works the same way as RARP, except RARP request packets request an IP address instead of a MAC address. Like I said, it's just the opposite. So if you look at the bottom here, device A, I'm sending a broadcast that uses my hardware address. So he sends a broadcast, right? Can someone on my network tell me what my IP address is? He don't know his IP address. He needs it to communicate. So he sends a RARP request, not an ARP request. And then the RARP server, which will respond to it and say, okay, your hardware address is blah, 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 blah. And your IP address is blah, 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 blah. You would think every device has a hardware address, but in cases like this, that's what a RARP server would do. Okay, so there's also Proxy ARP is another type of ARP. RFC 1027. I'll leave a link in the description below if you want to learn further about that. Again, these links that I'm gonna put in below, you don't necessarily have to read it. If you just a real white paper nerd, you can just look at the RFCs at the bottom. This gets deeper into what I'm doing. I'm just giving y'all the basics and just kind of like a basic summary of these topics. So proxy ARP is basically you have somebody representing somebody else to respond to an ARP. you'll see the term proxy a lot in the IT field, because there's devices or websites that would act as or represent something else. So in this case, you have, if you look at this image here at the bottom, this computer is trying to get the IP address 3333, right? He's not on his network, so he sends a ARP request, and then this router acts as a proxy ARP. He's gonna respond and say, "Oh, that's me," even though 3.3.3 is somewhere in here. He's gonna respond for him. He's gonna start communicating. Okay, so now every time he communicate, he's gonna communicate. It's kind of like a DHCP relay agent, which we're gonna discuss in the next topic. I don't know why they ain't call it DHCP proxy. Maybe because there's too many proxies. You got proxy server, proxy websites, etc. So a proxy ARP, again, is when you have a router responding for somebody else. As you can see right here, as implemented to enable devices that are separate in the physical network segment. So he's responding because 3.3.3 is in another network, but he's connected to that router and he knows where it's at. This guy knows where 3.3.3 is at. But anyways, connected by a router in the same IP network or subnetwork to resolve IP to MAC addresses. It's just like regular ARP, but it's just that he's responding for somebody else. When devices are not in the same data link layer network, layer 2, but are in the same IP network, they're in the same layer 3 network. So he could be like, I don't know, he could be like 3.3.5 or something like that. So he in the same IP network, but he's not in the same layer 2 network. In other words, they are not in the same local area network. That make any sense? They try to transmit data to each other as if they were on the local network. And there's also SLARP. So yeah, you got SLARP, RARP, PARP, like proxy ARP. It's a whole bunch of them, but SLARP is basically serial line address resolution protocol. So it's basically ARP, but for serial links, right? If you notice here, you have this new COM server, you have existing server, right? Or device, whatever. The IP address of existing is 172.30.10.1. So that's his IP address, right? He don't have an IP address, so he needs to request one, kind of like DHCP. But SLARP, basically, he sends a SLARP request, right? Not an ARP request, but a SLARP request, right? Through the serial link. That's why it's called SLARP. And then he learns that existing is 10.1. From that, he's able to deduce that his is going to be, okay, since he's 10.1, I must be 10.2. And that's what SLARP does. So he sends that request and he gets the reply through existing. He don't give him the IP address, but he just kind of learns it that way. And also there's authorized ARP. I believe this is the last type of ARP. Authorized ARP, you use these in like public networks like Starbucks or like at a hotel or something, right? This is more of a DHCP topic, but you can use this for security purposes because you're only, because you can spoof MAC addresses. And this would help kind of mitigate that problem because you only letting certain it's just kind of like MAC, it's almost like MAC filtering, but you only filtering ARP entries in your database. So if you look here at the bottom, router 2, this could be a PC. He sends a request for an IP address. That's why I said this is more of a DHCP topic. So I'm not going to get too into deep in this. I may do it in the next topic, which is DHCP. Let's make sure. Yeah. So the next topic is DHCP relay and server. So we may get into that more in the next topic. And then he assigns an IP address and install secure ARP entry for it. The way you do that, I'll show y'all in a second. Actually, I'll show y'all right now. Console router 1. You do that through the interface. So you're gonna configure terminal interface. Let's say I believe it's, let's do one for this line right here. That's Ethernet switch 1/1.0, right? Ethernet 1.0. and then you do ARP authorize. That's basically how you enable that feature. So now that port, once I enter that, you enable authorize ARP. And then after that, that's how he installs a secure ARP entry for router in router 1. So once he does that, he binds his MAC address and his IP address. He binds it in his ARP table. And then he's going to send periodic ARPs to make sure router 2 is still active. He's just going to be keep polling it. I believe the default is either 60 seconds or 30 seconds. Every 30 seconds he's going to poll for him if he's online or if he's just logged off. Once he's off, he's going to remove that entry. He'll keep replying. So once he's online, he'll keep replying like, yeah, I'm here, I'm still here. I'm still here. You know, you could use, like I said, you could use this like at a hotel or like at like a coffee shop or something like that, and basically making sure that that person is still online. Once they're offline, then you remove that entry, and you use that. You wouldn't use that like if you want to time their sessions and charge them for their sessions, and then you won't get anybody coming online to your computer or on your network and spoofing a MAC address and using your services without your permission. But again, this is more of a DHCP topic, so we may discuss that in the next section. Actually, there's one more. It's inverse ARP, so I guess that's IARP if you want to call it that. This is more, I didn't really discuss this in frame relay. I should have. This is more if you need to map a layer 2 to layer 3 with frame relay. Remember, frame relay don't use MAC addresses, it uses DELCs, right? So basically you know the IP address of the remote device, but you don't know its DELC. So you send an inverse ARP, and that's how you know it's DELC. Remember, normally DELCs are locally created, and you know only the DELC that's mapped to a specific address. But you could use inverse ARP to learn its DELC, a remote device's DELC. As you can see right here, the official definition is inverse ARP, which is enabled. It's also used for ATM networks. ATM frame relay X25, which is not really used today, builds an ATM map entry or frame relay map entry and is necessary to send unicast packets to a server. We discussed what unicast is. If you don't know what that is, go back to the last video. Or relay agent on the other end of a connection. Inverse ARP or INARP is used to find a layer 3 address, IP address, from a layer 2 address, which is the DELC. And let's go ahead and discuss what an ARP cache is. ARP cache is basically a table of your DHC or your IP to MAC address bindings. So you know, once you learn the MAC address of something else, you already knew its IP address, so you able to deduce that, okay, this MAC address goes to that IP address, and you just keep this table here. This is the official definition. ARP caching is the method of storing network addresses and the associated data link addresses or layer 2 addresses in a memory for a period of time. You can clear these out. You can set the aging timer. You can modify all of that. This minimizes the use of valuable network resources to broadcast for the same address each time a data is sent. So that way, you know, it kind of like helps you remember the stuff. Otherwise, you would keep sending ARP requests to try to get the MAC address of another device. That would cause too much flooding. We discussed what unicast flooding was, or unknown unicast flooding was. If you don't know what that is, go to, I believe, the second video, general networking challenges. So we don't want we don't want too much flooding on our network. This helps resolve that problem by keeping the ARP cache. And they time out if they become outdated, or if we retire devices from our network, whatever, or if we just haven't heard from a specific device in a long time, we just delete it from our ARP cache. That's what this table is for. Cache entries must be maintained because the information could be, like I said, become outdated. So it's critical that the cache entries are set to expire periodically. So it's good to have an aging timer. As you can see right here, we got the protocol IP, we got the IP addresses, we got the aging timer of when they will age. You can set that up, you can modify it. I can show y'all that if I have time. I want to try to keep these videos short. This is the MAC address. This is the encapsulation type. I'll show y'all what that is in more detail. And then this is the interface that we learned it from. Now, when I first was learning about ARP cache and I heard that definition, I thought to myself, like, well, ain't that the same thing as a CAM table? But no, if you remember what CAM table is, CAM is content addressing memory table. And that is stored on a switch, and it keeps layer 2 entries. This keeps layer 2 entries too, but the difference, as you can see here, a CAM table maps MAC addresses found on the ports, not necessarily the IP address. So if you look here, the CAM table doesn't keep IP addresses. It keeps the MAC address, what VLAN is in, if it was learned static or dynamically, meaning automatically, or you entered it, and the port it was on, it was learned from. That's what a MAC address is. We learn that by doing, or we keep the table, but we view the table by doing show MAC address table. The ARP cache is different. We keep IP addresses and map them to the MAC addresses. We view that with using show IP ARP and show ARP. So the CAM table and the ARP table, ARP cache, are not the same thing. I used to think it was the same, but it's not. That's the difference there. Pause if you want to look at it, but that's the difference between the CAM and the ARP table. Now let's go ahead and move on to a little bit of labbing and just kind of play with the ARP table a little bit. We'll delete some entries, we'll enter some entries. We're just gonna play for it with a little bit. You need to really do this on your own, but I'm just gonna show y'all if y'all don't have time for all of that. Just, but you really want to be hands-on with it. That's how you learn, how MAC address tables work, how they remove entries, how to delete them. One time I was trying to figure out how it wouldn't come out, and I figured out the reason why. Maybe if I have time, I'll show y'all that. But it's best to try to learn how to lab and do this stuff on your own. We lab every day. You got to be hands-on every day. I'm telling y'all. All right, so I got Solar Putty launched here. This is our GNS3 topology, right? We're going to be playing with these two guys right here. PC1, PC2. They're basically in the 172.20.5 network. These two guys right here, right? Hopefully I don't have any MAC entries for them. First, let's discuss these show commands. So yeah, we did the ARP authorize. That's how that's how you enable ARP authorization. Again, this is more of a DHCP topic, but let's go a little deeper into that though. We got with ARP. Actually, yeah. So let's go into this is what we got for ARP. You got the standard ARP protocol, which if you look at a ARP table, do show ARP. You notice the type, we've got ARPA and ARPA, which stands for, that's the standard ARP protocol. That's by default. That's what it's set to. Authorized, again, is to allow internal authorized ARP entries. So if you say, okay, this IP address, you're going to know the IP address. You're going to map it to a specific specific MAC address to a specific IP address. You're going to put it into your ARP cache and only allow them at specific times. And you'll keep polling for them until they're offline. From that way, again, that's what you would use at, like, say you want to charge internet services for public Wi-Fi. That's best used for those type of applications. You also got frame relay, ARP frame relay. So you're going to enable the encapsulation on this interface for frame relay. And then you can set the probe parameters. That's for ARP authorization. So you're going to be, you can send as many messages. You can send it at these times. Probe for that many seconds. You got to do interval. And then put how many seconds you want to keep probing from to see if he's online or not. Then you got SNAP, which is basically, I can't even remember what it stands for, but enables encapsulation for, I believe, like token ring and affiliate networks. That's like some old school technology. Don't even worry about that. I wouldn't even worry about that. So the timeout, that's basically when you set the ARP cache to basically time out or remove an entry. All right, so let's go ahead and right now, let's go ahead and see what we got in our ARP cache, which I believe we already see right now. So basically you do a show ARP. Yeah, show ARP. Basically, show ARP is the easiest way. So right now we only, as you can see, we know the IP address 5.1 to that MAC address. We have it through our interface Ethernet 1.0. What is that? We look at a topology. 5.1 is actually the Ethernet 1.0 interface right here. As you can see, I'll show y'all real quick. Show IP interface brief. That's this guy. 1.1. That's the fast Ethernet 0.0 interface. That's this guy right here. So yeah, each one of them got MAC addresses. These guys right here got MAC addresses, right? So we don't know the PC's MAC addresses yet, right? How are we gonna get them? We could either have him poll for it, or we could either have him poll for it. Let's go ahead and have the PC try to get it. So his default gateway is actually that right there, which is 5.1. I didn't put a note for it, but that's his default gateway, right? So let's go ahead and go to PC. Let's go ahead and console in the PC1. This PC1 right here. Let's have him ping. Oh, he can't find his DHCP server for some reason. Oh, maybe because I didn't set it his. Let's do this. IP 172.16. Or 20.5.10. 20.5.10. So 20.5.10. We're gonna make him 5.10, and he's /24. His default gateway is 172.20.5.1. He's checking for a duplicate address. Boom. Now he's got a gateway. Let's go ahead and move on to PC2 and give him his IP address 20.5.20. So IP 20.5.20/24. His IP address is his gateway is 20.5.1. Checking for duplicates. Let's go ahead and ping the gateway. 172.20.5.1. And we got some replies. So we got PC2. I don't think I showed y'all this one. PC2. He is now also pinging the router. Now let's take a look at router 1's ARP cache again. Show ARP. And now we got entries for both 5.10, which is this guy, and also 5.20. So we have both their IP addresses. We also have their MAC addresses. This is the encapsulation tag, ARP A. This is standard, right? That's by default that comes in. And then we learned these IP to MAC or MAC to IP bindings on the interface, Ethernet E10. What else could we do here? We want to remove these guys. We do clear IP ARP, right? Actually, clear IP is clear IP ARP, and then you got to put the exact IP address. So let's remove PC1, 172.20.5.10, right? Remember, these don't age out. You can't even do, I think, no ARP or whatever to remove it, right? So clear IP ARP, the IP address. Let's do a show ARP. It's still there. It's still there. Age a minute, 1 minute. Why is it still there? Actually 10. Why is he still there? Let's remove it again. Let's try it again. Clear ARP cache, clear IP ARP, 5.10, show ARP. It's still there. You kind of clearing the aging timer. It's still going to be in there. So unless I turn that bad boy off, unless I turn him off, or I don't even think, I think if you do no ARP, it won't even go away. I think different routers work different ways. So let's try that. Let's try, I believe, no ARP. You can't even do that, can you? No ARP. Nope, that's not supported. What else could we do to try to remove him? Let's just turn him off. Let's see if we turn him off. Stop. Right? Let's clear IP ARP. That's 5.10, right? Show ARP. And now he's gone. We still got 5.20, and he's been in here for 3 minutes so far. Right? So we had to turn him off to actually remove it from our ARP entry. I don't know if it's something wrong with my iOS or if it's working as designed. You leave a comment in the description or you leave a comment below and you let me know. But I had to turn it off to remove it. Let's what else could we do here? We could also define a static entry. I'll show y'all how to do that. Let's just create an arbitrary IP address and an arbitrary MAC address. We'll just say we go to enable mode. We already in enable mode. Configure terminal, and we just do ARP. Right. I'll show y'all the entries. You just put the IP address. So let's just say it's 172.20.90. Let's say 5.99. Right. And then we need to do his 48-bit MAC address. Let's just do AABB.cc03. Let's say 99.99, right? After that, you got to define the protocol type. ARPA is a standard. These other ones are like FDD and token ring. Like I said, that's like old school networking technology. These other ones, this is like HP, like HP. Hewlett Packard interfaces. That's the type you really don't got to mess with this. You just go with the standard ARP type, because if you try to do it by itself, it's incomplete. So let's just go with ARPA for now. ARPA. That's the standard ARP type entry, or encapsulation rather. And that, now we exit out of this. Let's just do show ARP, and there he is right there. It's a fake. It's a fake entry, but we statically entered it into our ARP cache. This guy right here, or this guy right here. Notice the interface is blank because we didn't learn it. We statically entered it. What else could we do here? We could set an expiration time. So notice how this guy, he's been in there for 5 minutes, right? Let's do a show ARP again. Show ARP again. He's been in there for 5 minutes, right? Let's change the timeout time. Right? We could do that by the interface. So let's change the timeout for the Ethernet 10 interface, right? That's when they'll time out. So we already in configure terminal mode, so we go to interface Ethernet 1/0, and then we're gonna do the ARP, and notice, my bad, ARP timeout, right? And then you can put how many seconds you want. Let's say we don't want to do it this quick, but let's just say they're gonna time out every 10 seconds. Right? You could also enable or disable proxy ARP by default. I believe it's already turned on. You just go to configure terminal, and then IP ARP proxy. You can enable it or disable it. I believe it's already enabled. So let's double check. Let's do our show run. Do we see any entries for nope. No proxies. We we got an ARP entry that we entered from earlier. So no proxies in here. Let's go ahead and just IP ARP proxy disable, and let's do a show run. And there it is, IP ARP proxy disable. Y'all remember what proxy was, right? Proxy ARP as implemented to enable devices that are separated into physical networks connected by a router. So by default, it's turned on. We have our router as a proxy ARP. So if we have a device somewhere on a remote network, which we could probably set up right now if we wanted to, we can have him ARP for that entry, and then he will respond. And lastly, you could go further into ARP by looking into the actual interface. So if we go into router 1, we perform a show interface Ethernet 1/0. That's this guy right here. That guy. And you can see the encapsulation type of ARP, which is ARPA. That's the standard ARP, remember? We have the keep alive set to 10 seconds. This is the ARP type again. The ARP timeout. Remember, we could change it by just doing ARP and then timeout at the interface level. Set it back to the default when y'all wasn't looking. And you could also do, instead of just show interface IP, you do show IP Ethernet 1/0. And hold on, show IP interface Ethernet 1/0. And then you're going to get your IP addresses, obviously. And this is your proxy ARPs. That's how you know if it's turned on or not just in the running configuration or the startup configuration, but you just do show IP interface and then the interface number. And I think that's all we're going to cover today. Next, we're going to do DHCP server and DHCP relay. If you like this video, please comment, like, subscribe to the network.